in this topology I have not set up any routing protocol, so I want to set up a routing so that these PCs can communicate with this other PC. Hello everyone, hope you are doing great. So today what we shall basically be looking is the networking concept, network design concept. So what you can see on the screen is called eNSP. It's a software from Huawei that enables us to simulate the network and also design it. So we shall be looking at the basics of configuring IP address, both static and automatically through the DHCP. Also we shall be looking about the routing protocols, specifically the OSPF protocol, which determines on how packet from the router to the destination or from end devices to end devices to the route. So I'll open just so this is what we are going to build. As you can see, we have here two routers. These routers have some interfaces. This interface G00, this interface G002. Also you have switches, PCs. So let's start. Create a new topology in the eNSP. So after creating a new topology, what I'll do on routers here sidebar, then I'll click that R, then I'll select this router, I'll drop it there, then select it again, bit here. After that, I'll go to switches. These are switches, where switches, this one, switches. Then I'll select this one, I'll drop it there, drop it there, drop it there, also drop it there. Click the end devices which will be using the PC. Drop it there, 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 there, drop it there, drop it there, drop it there, drop it there. Now let's go to cables. Select copper cable, then I'll connect it to the other one, to the other interface, then connect it to the other interface. Do the same. So basically what I'm doing, I'm just connecting the interface together. So I'll do that. So basically what you need to know that a router determines the best path for data packets to travel to destination, whereby a switch connect multiple devices, and a switch will always forward data directly to its destination, unlike hubs which broadcast to the entire network. So I'll still drop it. It's still connecting the cables. Alright, this side done. Let's go to this side. Gigabase 3, connect it there, there, connect it there, 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 connect there, there. Still connecting there, there, there. Alright, we are done connecting the cable. So we shall just start all the devices. So as you can see now, all devices are now booting. So what first we are going to do, we are going to assign them an IP address so that they can communicate in the network. So I'll just use this text box, then I'll just start assigning IP address. So I'll start assigning IP address from each interface. So like I'll drop it here, then this I can assign 10.0.1.0/24. Then do same for this interface, 10.0, let's call it 2.0/24. Then repeat the same here. So I think I've assigned IP to all the interface. So these are basically interface. So this router has 1, 2, 3, 4. This router has 4 interface. This router has 3 interface. Yeah. So what we're going to do is that we're going now to assign IP address to each PC. So like this, I can call it dot one dot. I can call it dot dot 5, then dot 9, then this I can call it dot 3. So we are basically just writing what we are going to assign to the devices. Now I'll just click this router. It will open a terminal. So this is R1. As you can see, it has already opened the terminal. So what you are going to do, we shall going to change this name to display our own name for the router, which is R1. So what I'll do, I'll just type just logging as admin, which is system dash view. I'm now the admin, therefore I'm going to change the name sys name, then I can call it R1. So you'll definitely see this this comment while you type the command. So you'll be definitely seeing things like this while you type the command. So what we'll do to hide it, you can just do undo tm. So that will remove these errors while you are typing the commands, the comments. So after changing the router name, I'm going to log in this interface. After logging in this interface, then I tell it that your IP address is this one. So to log into interface, just type interface, then G0/0/2, 0/2. So I have logged in on this interface. Therefore, I'm going to assign it an IP address. IP address. Your address is going to be 10.0.1. Oh, I forgot to assign also the routers. So the routers we can give it .1. Can give it .1 for all interface of the gateway. We give it .1. So basically, all this interface gateway, the IP address will be .1 for our case, but you can assign your own. So I'll give it .1. Same here, .1. For this side will be .2. .1. .1. So back to the router. So I'll assign IP address 10.0.1.1. This one 10.0.1.1. So that will be its IP address. We are not putting .0 because this just shows the network. Then we shall put the subnet mask, which is 255.255.255.0. So I can see it has now entered in the app state. That interface has entered in app state. As I can see, the error message are still coming, the comments. So I'll just quit to normal user, then type again the command undo tm. Yes, you can see the current terminal monitor is turned from. So we are not going to see comments like this one. So after we have configured that one, we can now configure the PCs. So I'll just come to this PC, log on it. Then we are now configuring the static IP. So what I'll do on the IP address, I'll type 10.0.1 dot now the IP, which is 5, this one. Then the subnet mask is 255.255.255.0. Then the gateway is the IP of the interface, this here. So what I'll do, I'll just type 10.0.1.1. Then I'll click apply. To test it, I can come here and ping the gateway, which is 10.0.1.0 slash 0. Yes. As you can see, it is saying that the destination is unreachable. Oh, I'm pinging the network. So what I'll do, I'll repeat. It's supposed to be .1. As you can see, it's now working. .1. Awesome. So I'll go to the next. Do the same. So the IP address is 10.10.0.1.9. This is .9. Then subnet mask will be just the same, 255.255.255.0. Then the gateway will now be 10.0.1.1. Then click apply. To confirm, then I just come and ping 10.0.1.1. As you can see, it's now working. I'll repeat now to the other interface. I'll repeat that one to all other interfaces. So for this one, it's done. So let's come back to this router. Let's now log into this interface. Let's just go first to admin system-view. Then log into the interface. G0/0/1 G0/0/1. Log in there. Then assign the IP address. Shall assign it 10.0.4.1.1. Then mask is 255.255.255.0. Awesome. So after that, we come to these PCs and configure them. So static, then IP address will be 10.0.4. This is .3. This is .3. Then the other one is .4. This will be the same, 255.255.255.0. Then the gateway will now be 10.0.4.1 here, this one. Then click apply. Then we can just confirm by pinging the gateway ping 10.0.4.1. As you can see, it's now working, meaning the packets are being transmitted. Let's do also this one. So IP address of this one is 10.0.4.4. Then subnet mask same 255.255.255.0. Gateway IP is 10.0.4.1. click apply, then come to commands, then test ping 10.0.0 point 4.1. You can see it's now working. Awesome. So let's come to this interface again, back to the router. Let's log into that interface. To log in, you just type interface, then this code here, which is G0/0/0/0/3. Enter. After entering that interface, we're gonna assign an IP address. Then the IP address, which is this one, 10.0.3.1. Then subnet mask 255.255.255.0. Enter. Awesome. After assigning that one, now let's go and assign the PCs. Here I will type 10.0.3. The IP for this one is 3. The subnet masks the same 255.255.255.0. Then the gateway will be 10.0.3.1. Then click apply. Awesome. So if I come here, then ping the gateway. So if this is PC, then the gateway will be this interface here. So this, we are not considering this switch because it's just passing the packets. We have not configured it, so it's just packing the packet. So the gateway for PC4 and PC5 is this one, this G003 on R1. So ping the gateway 10.0.3.1. As you can see, it's now working, meaning our configuration are correctly. Then go to PC5, do the same. 10.0, then 3, then .4, this one. Then subnet mask the same, 255.255.255.255. Sorry. Then gateway 10.0.3, then 1. Gateway is .1. Then click apply. Then come to here and confirm ping 10.0.3.1. As you can see, it's now working, meaning our configuration is correctly. So all this this side is already configured, this and this. So let's go to the other side and do the same. We shall come here and click R2. These are the other router. So before we go to the other router, we can just come here and also configure this G00 interface. So I'll log into the interface G0/0/0/0. After logging into that interface, I'm gonna assign the IP address, which is 10.0.2.1, then 255.255.0. That is the subnet mask. After that one, it's now okay. Then let's go to this one, then configure both interface. Before that, I will disable the commands that appear when any commands is executed, or the comments. So I'll just type undo tm, then it will turn the current terminal monitor off. So I'll just log in as the admin, system view, then change the router name, system sys name, then the name of the router, which is R2. After that one, I can just now log into the interfaces and assign the IP addresses. interface, then G0/0/0, sorry, 0/0. After looking to this interface, I assign the IP address, which is this one, 10.0.2, 10.0.2.2.2.2, that way, since it's .2. Then 255.255.255.0. I've mistaken somewhere. 1, 2, 3, 4. And recognize command. Sorry, I'm supposed to type IP address, then the IP 10.0.2.2, then subnet mask 255.255.255.0. Done. Do the same to the other interface, this G002 and G001. So I'll just do the same. Log into that interface, which is G001. After logging into that interface, then we assign the IP addresses, which is 10.0.5.1.1. Then click enter. Do login to the other interface, which is 02, this one. Then assign the IP address, which is 10.0.6.1. Then the subnet mask, click enter. I think we have done configuring everything. So what I'll just come, we have finished configuring each of the interface. I'll just come and quit. After quitting, I can just save, or I'll just quit again. Awesome. Then I can save the configuration. Then click yes. Then I just click enter. As you can see, it has saved successfully. I'll also come to this other side, then quit, then click save, then click yes, I want to save, enter. It has saved the configuration. So let's come to this end users PC, which are computers, then assign the IP address manually. So we'll start with this one. Alright, what is the IP address? Its IP address is this one, 10.0.6, but now it is on .3. Subnet mask the same, 255.255.0, then 255.0. Then the gateway is 10.0.6.1. Apply. You can just log into the PC, the terminal, then confirm ping 10.0.6.1. It's working. Let's go to the other PC and do the same. 10.0.6.4. This one here. Subnet mask 255.255.255.0. Gateway is 10.0.6.1. Then click apply. Awesome. So it has test ping 10.0.6.1. It's working. So let's also configure this one. 10.3. No, 10.0, 10.0.5.3. Subnet mask 255.255.255.0 gateway 10.0.5.1. Click apply. Test it. Ping 10.0.5.1. It's working. So let's do the same for this one. Ping, let's first assign its IP address is 10.0.5.5.4. Subnet mask 255.255.255.0. Then the gateway is 10.0.5.1. Click apply command, then ping 10.0.5.0 supposed to be .1. Wow, awesome. As you can see now, we have now configured the IP address manually in all the PCs. Now what you need to note that this PC can ping this one, can also ping this one, ping this one, ping this one, and ping this one, since the router is able to route the packets here. But when we try to ping this PC6 to like this PC10, it won't work because we have not configured any routing protocols. So this router only knows this interface, and this interface, this IP ranges of this interface, but it doesn't know this one and this one, but it knows this one, meaning you can ping this one up to here. So what we'll do, we can just confirm that. So I'll log into this PC. I'll just try to ping this one. So to ping this one, I'll ping 10.9, 10.0.1.9. As you can see, it is working, meaning this PC can communicate with this one. What about this one? Let's do that one. So this one is on network .04, then .3. Then let's ping. As you can see, it is now working. It timed out the first one since it was looking for the route. Now that it is working, so let's try. So meaning if it can ping this one, then it can ping this one. So let's try also this one. .3 ping. Timeout. As you can see, it's now transmitting the packet, meaning this PC can communicate with this, and this, but it can't communicate with the other PCs on the other side. So if we ping, let's ping for the other side like this one, .4. So it will be 10.0.5.4. As you can see, the request is timeout, meaning the packets got lost as they were being transmitted. So we shall be looking that on the next video. So in this video, we have learned how to configure the IP addresses manually. Also in the next episode, we shall going to learn how to configure the PC automatically using the DHCP. Alright, now let us learn how we can configure IP addresses automatically through the help of DHCP, which stands for Dynamic Host Configuration Protocol. So this protocol will enable us to assign IP addresses to each of the PC automatically without manually configuring. So what I'll do, I'll just click R1, then on router 1, then I'll undo TM. This will turn the current terminal monitor off. After that, enter at the admin, which is system-view. I'm now at the admin. Then I'll enable the DHCP by tapping this command, DHCP enable. The operation may take a few seconds. Please wait for a moment. I think it is already done. Then I'll use these commands. I'll create an IP pool. If we go to edit here, IP pool, then we can call it even LAN1. So I'll come here and create an IP pool, then I can call it a LAN1. After that, click enter. As you can see, we've already logged in into that IP pool. Then we shall go into tell it the network and the mask. So I'll come here, type network, then type the exact network, this one. We are starting with this one, this interface, then this one onwards. So I'll just type 10.0.1.0 mask 24. Awesome. Next, tell it the gateway. So the gateway is 10.0.1.1. So this is the gateway here. Awesome. After that, we shall log into that interface, then DHCP select global. So what I'll do, I'll just log into that interface 10 interface G, this one here, this is the interface G 0/0/2/2. After logging to that interface, what I'll do is that I will type this command DHCP select global, DHCP select global. Done. That's how we set up the DHCP. So to confirm it's working, I'll come to one of the PC, then change from static to DHCP, then click apply, then I'll go to terminal, then request for new IP by typing this command IP config /renew. Then you can see it is contacting the DHCP server. As you can see, we have now been issued the IPv4 address, meaning it worked correctly. We can even ping the gateway to confirm that. Ping 10.0.1.1. You can see it is now working. So I'll do that to this same PC. Apply, click apply, enable DHCP, then apply, then request for new IP config /renew. It is requesting. Just wait. You can see we have been issued .253. You can ping the gateway to confirm 10.0.1.1. It's working. So let us again configure on the next. Let's configure. All right, now let's configure on the next interface. This one interface. So what I'll do, I'll repeat the same commands again. Since the DHCP is enabled, I'll not repeat that command. So I'll just repeat. I'll type this one, IP pool. I'll create another IP pool. Here I can just quit. Then I'll create another IP pool. Let's say LAN2. After creating that IP pool, then I repeat the same network mask. Network for these two is 10.0.4.0 mask 24. After creating that one, then the gateway which is 10.0.4.1. After that, I'll log into the interface. Then that interface switch is this one. I think it is G001, if I'm not wrong. G001. So I'll just come to the command interface G0/0/1. Yeah, then I'll type DHCP select global. Awesome. think it is enabled. So what I'll do, I'll come to this PC. After coming to that PC, I'll come to basic config, then use DHCP, click apply, then request for a new IP by typing ipconfig /renew. Just wait for it to be issued the IP. As you can see, it is working. It has been issued, meaning it's working. We can confirm by typing ping 10.0.4.1. This you are pinging the gateway. It works. Awesome. Then we shall repeat the same here. Come here, DHCP, click apply. Come here, then request new IP by typing ipconfig, /renew. Then wait for it to be issued the IP configuration. As you can see, we have already been issued. It's working. So let's do the same for this interface. So again, I'll come to the router, then I'll quit here. First, I'll create another IP pool. IP pool, let's call it LAN3. On that IP pool, I can tell it the network, then this is the network 10.0.3.0 mask 24. After that, after telling it the network, then I can tell it the gateway, which is 10.0.3.1. After that, log into the interface, which is G003 G0/0/3 then DHCP select global. Done. So if I come here on this PC4, then enable the DHCP, click apply, come here, request for new IP config /renew. Let's wait for it to be issued the IP by the DHCP. Done, it's working. It has been issued, as you can see the IPv4. So I'll not ping that one. I'll just do it enable for this other one, the same DHCP apply, then IP config /renew, obtaining the IP configuration. Done. We have already gotten, meaning it is working. So we have already enabled the DHCP for this, and this. So we can also go to this other side and do the same. So first, undo tm, login as the admin, system-view, DHCP enable. After enabling the DHCP, now let's create an IP pool. IP pool. Let's say LAN 1A. After that, network, then the network, which is this one, 10.0.6.0 mask 24, gateway, then 10.0.6.1. Just forgot an E, gateway, that way. After that, log into the interface. Interface is G0, this one, G0/0/2. After logging into the interface, type DHCP select global. Awesome. So it's already done. Then I come and update the PC by selecting DHCP, click apply, request for new IP config /renew. Let's wait for it to be issued the IP. Awesome, it has been issued. Repeat the same on the other PC. DHCP, click apply, request phone IP config / renew. Awesome, it has been issued. Then after that, this side is done. Let's go for this side. For this side now, let's again come to the router. Let's quit here. Then let's create another IP pool. LAN 1B. After creating the IP pool network, then the network 10.0.5.0, mask 24. After that, gateway, then 10.0.5.1. After that, interface, log into the interface, G0/0/1. After logging into the interface, type DHCP, select global, done. It's already done for this side. So let's come to the PC, DHCP, apply, request for new IP config / renew. You can see it's now requesting. So let's wait for it to request. It is working, it has been given. Let's do for the same for this other one. Basic DHCP, apply, come here, then IP config / renew, waiting for it to be issued the IP. Done, it's working. So I think we are done, and that's how we set up DHCP in eNSP. So in the next episode, we shall be looking on how we can set up the routing. We shall start with static routing, then OSPF. Peace. So static route enables the PCs to know where to send the traffic, or let's say the routers where to send the packets. So for our case here, this router knows this interface, and this interface. So like this, when this tries to communicate with this, they can, since it will just contact the router, then the router forwards back, send back the packet. So packet, if sent with the PC6 to PC3, it will work since it is in the same router. So the router has already known the routes to where it will send the packet, since it is using the route table. So what if this PC6 wants to send the packet to, let's say, PC4? We can just try to ping again. Let's ping that. So first let's check our IP config. IP config. So right now our IP is .254. What about for this PC? IP config for this one is also .254, .5.254. So let's try to ping. So it will be 10.0.5.254. Yes, .254, that way. Then I try to ping. Let's come here, then ping. As you can see, the request is timeout, request timeout. Why? Because this router doesn't know about this other router, and we can only, how do we tell this router that we have this other router or these other routes? So what we'll do, we use what we called routes. So in networking, we have two types of route. We have a static route and uh, a dynamic route. So static route is where we configure manually by ourselves. But when it comes to dynamic routing like OSPF, this router, they are able to know themselves the route. So if, for example, a certain router fails, the other router can update their route tables. Therefore, they know the perfect route to which the data will reach to its destination. So to configure static route, we have to tell we have to tell this router about the other network. And how do we tell it? So we just come and log in it into the terminal. After logging into the terminal, go in as at the admin system view. After the admin, there's just type IP route static dash then static. Then here the network where the traffic is you want it to flow. For our case, we want this network to communicate with this network. So what we'll do, we'll type IP route static, then the destination. So the destination network is this one. This is the destination network. So we shall just type it there. 10.0.5.5.0. Then the subnet mask 255.255.255.0. Then the next thing is the hop. The next hop. The next hop means the entry to the other network. So which is the entry to the other network? Is basically this one. This is the next hop, since this is the one that is connected to this one. So this traffic can reach this one here. Therefore, this is the next hop. So we shall just type the IP of the next hop. So IP of the next hop is this one, 10.0.2 10.0.2.2. Think that one is okay. Awesome. So now we have created a route from here all the way to here. So meaning if we ping, this PC should work, but this pinging this should not work, since we have to also create an opposite route. So let's just try. As you can see, the request is still timeout. Yes, the request is still timing out. Since this is reaching this one, then this one is forwarding. So first, let's check if let's assign this IP to this interface. If it is not assigned, let's just try to assign it again. So we shall log into that interface, or we can just come here. Let's try to ping the gateway. Ping 10.0.1.1. It's working, meaning the traffic is able to reach here. So let's now try to ping this other side. So 10.10.2.1.1, 10.2.10.2, 10.0, 10.0. So we are pinging this gateway, it's working. Now let's ping this one, which is 10.0.2.2.1. As you can see, it is now working, meaning this traffic is coming here, then passing up to here. Now from here it is reachable. Now let's try to ping this other one here, .2. So as you can see, the request is timeout, meaning there is an issue here. So let's check if the IP is assigned on that interface. So let's log in on that interface and assign it. Then system-view interface G 0/0/0. After that, IP address, let's assign it 10.0.5.2. Point 2, oh, I forgot the mask or the 255.255.255.0. The specified config another. So this means we have already set up the IP address here. So let's try. So meaning we are pinging here, it get lost here. So let's try to set up the opposite. So I'll just quit. After quitting, then I type IP static IP route static, then the destination network. Our destination network is 10.0.1.0. that is the destination network, 10.0.1.0. then mask yake ni 255.255.255.0. after that, the next hop is the entry to the other network, which is this one here. So 10.0 10.0.2.1. Yes, I think yes. Awesome. So let's try again. Still request. As you can see, it's now working. Yeah, that's how we set up the static route. So meaning this PC is able to communicate to this one. Let's try vice versa. So let's ping the other one, this one. Its IP, let's find its IP. IP config is .254. So ping, then the 10.0.1, this one, 10.0.1 dot what, .254 is working. So that's how we set up a static route. So what you need to note that we have only set up a static route from this network going to this network. What about this other network? We can try to ping and confirm. So to ping, I'll just come to one of the PC, then confirm its IP, which is .253. So then I come here, .253, which network .6. Then click enter. You can see a request timeout. Therefore, we need to repeat the same thing to create another route. Or what we need to note there, not here, we have created a route here for this one here. So traffic going to this network will be none. We reach here, then travel, then the other side, then the other side, come back. So I think traffic, so I think what we should do here is that so this and this can communicate with this and this. That's true. What about this and this? So this and this will send traffic here, and it will get lost. It won't know where to go. So we need to come here and do the same. So I'll come here. After coming here, let me quit. Then system dash view. Then I'll use the same command, IP static route. Then I'll put the destination network, which is this other network, 10.6. Now we'll just change here to .6. Then the hop will just be the same hop, then this one, enter. Oh, awesome. Then, so now this means that traffic here cannot reach this network. Therefore, we need to do vice versa, or we can just confirm. We can just come to this PC. Let's just confirm IP of this 253. Then come to this. Let's try to ping. Let's try to ping this one. Ping. Let's try to ping at 10.0.6.0 slash what, not slash dot 253, request timeout. So we need to create now the opposite route. So we have created the route for, remember the first one we finished. So this network can communicate with this network. So we are here. You have already configured the route, like the route for this one. Yes, the route for coming to this way. Now we need to create an opposite route for coming to this way. So to do that, we just come here. Then I type the same command, then type the destination. The destination is .04 here. .04. Then the next hop will just be the same. Then click enter. I think it should now work. Let's come and try. It's working. So meaning this and this network can communicate with this network and vice versa. What about this one? We still need to do the same. So let us try. I think let's just try. So this is .253. Let's try 10 dot ping 10.0 10.0.6.0 dot 253. Request timeout, meaning we have to set up the route here. So we come here, then repeat the same command. Destination network .6. So I think we have already set up the two destination network. We just need to set up the vice versa of it. Just telling this router about the other network here. Here's where the magic comes from. Here. Then update it to .3. Create another static route .3. Then the next hop is that one. We are done. It should now work. So let's try. Still there's some issue. So I think this IP has a problem here. .6.0. Is it .6? It is .0.6.0.6. It's working. It's working. So let us try this communicating to this other network. So let's find the IP first. .254. So let's try to ping .254. Then the network is .05. It's working. So I think we are done. That's how you set up static routing in eNSP. Peace. Hello there. Let us now continue with OSPF, Open Shortest Path First. OSPF is basically an IGP protocol used within an autonomous system for packet routing. OSPF is also described as link state protocol, which means the route selection takes into account parameters like bandwidth. As you can see, this is how OSPF works. OSPF is an IGP protocol, interior gateway protocol. So as you can see, this is a larger network, then OSPF is inside here, inside there, it handles the routing inside there. But between big networks and other big networks, it is basically IGP protocol. A good example is BGP, if I'm not wrong. So for our case, we are focused with this one here, which is OSPF. So without further ado, so let us just start. So this is the command to set up OSPF. So I'll just copy it, then go to eNSP. So in this topology, I have not set up any routing protocol. So I want to set up a routing so that these PCs can communicate with these other PCs. For we can just confirm they are not communicating by typing the, let's try to ping this one, which is 10.0.5.4. So you can see request timeout. All right, now now the first step, go to the router R1, then login as the admin, system dash view, as it is saying error since I'm already the admin. So after that, type just OSPF, then OSPF 1, or let me paste the command. So you just type OSPF, then the router ID. For our case, we shall use 1, then router ID, we can use router ID, then 1.1.1.1. think that one will work. Then we shall enter area 0. To prevent this type of comments while you're typing commands, you can just quit to the user view. Quit. So now this is the user view. Now type undo tm t then space m, then monitor current off. Then let's go back there. System dash view OSPF 1, then router ID 1.1.1.1. inside there type area 0. We are now in the area 0. Now we need to advertise all the networks in the OSPF so that OSPF will be aware of the networks to be included. So I'll just type network, then the network. We shall start with this one on this interface 10.0.1.0.1.0. Then instead of subnet mask, we will type the wildcat. Wildcat is basically a reverse of the subnet mask, where we change 1 to 0 and 0 to 1. So for our case, subnet mask is 255.255.255.0. So the wildcat will be 0.0.0.255. Yes, then click enter. Then do for the other interface dot 4, this one dot 4, then dot 4 first, then dot 3. Just type the same command, then change this dot 3, then dot 2. Done. Now we have done setting up OSPF in this router. Now let's go to the other router and do the same. So on the same, I'll type OSPF as I'll log in as the admin, then type OSPF, then the router ID 1, then some other router ID, then I'll give another value 2.2.2.2. Then I'll enter area 0. After entering area 0, then I'll tell OSPF about all the networks that is need to focus on. So I'll just type network, then 10.0.5.0, then the wildcat 0.0.0.255, that way. Then repeat the same for the other network, which is .6. Then repeat for the other network, which is dot 2. Awesome. OSPF done. So we are now set up for this side. Now let us try to ping again the same 10.0.5.4. As you can see, it is working, meaning OSPF is routing the packets perfectly. So let's try even this .4. So it will be .6.4.6.4. It is working. So let us also come to this .4 and ping this .5. So it will be .1.1.5. It is working. So the request timeout for the first time since it was looking for the route. And now that is how you set up OSPF in eNSP Huawei. So if you like, you find this video helpful, feel free to like, share, comment.